Great. So today's talk is, as you are already aware, about off-chain scaling solutions. So why do we need scaling? First, a little motivation. So if you're moving from a centralized payment system to a decentralized payment system, there are actually many questions popping up. In a centralized system, if Bob is sending a payment to Alice through a centralized party, we know very well the security properties that are in place because the bank is just like the anchor of trust here. We know the privacy requirements, only Alice, Bob, and the bank knows about the payment. And we know how fast the bank can scale the payment flow, because the more they can process as central entity, well, the more transactions we have. But if we now remove this central entity and replace it with a cloud of miners, developers, and a peer-to-peer network, well, there are many questions that are popping up. So in particular on the security side, on the privacy side, but recently and even more importantly now on the scalability side. So I just want to briefly speak about on-chain confirmation of transactions. So let's assume we have a couple of peers that are sending transactions, that are creating transactions. So these are just users like you and me that want to send payments to other participants. These transactions, they're basically reaching a set of miners, those that are extending the current blockchain. And once a lucky miner finds a block, he can include this transaction within the blockchain and then propagate it within the network. And transaction security is basically relying on the fact that if you have a blockchain and there's a particular transaction which is included in a block B1, then an adversary should not be able to construct a parallel blockchain, also called a fork, to basically double spend this particular transaction. So the red transaction, which pays the adversary here, should not, the blockchain, the red blockchain, should not be able to be constructed. So an adversary might choose to perform an override action if he is able to create this longer blockchain, effectively overriding the current honest chain. So if you do that, then later on the honest chain or the honest miners, they will just continue working on the longest chain. So this is transaction security for on-chain transactions. And many people might have told you, okay, how many confirmations do you need in Bitcoin for a transaction to confirm? Tell me.
Six.
Why 6? How do you come up with this number?
Probability is very small.
So the probability is true. The longer you wait, the more unlikely it is that an adversary is able to double spend your transaction, right? But these numbers are actually they're not really, 6 doesn't mean anything. And actually the number should change over time because the network is changing, the resilience of Bitcoin is changing. Actually the security of a Bitcoin transaction is dependent on the Bitcoin price. And this actually applies also to other blockchains. So it shouldn't be constant. It should be something flexible. But just for the sake of this talk, I'm going to show you that, so in my PhD thesis, I've shown that, for example, 6 Bitcoin block confirmations are equivalent to 37 Ethereum block confirmations, given an adversary with 30% of the hash rate. Okay? So these are static numbers. It's just for a particular instant of the network that I measured at the time. But you can basically calculate then the time that it would take. So in Ethereum, this would take about 10 minutes, given a 15-second block interval on average, and about 60 minutes in Bitcoin. So you can also extend this to other blockchains like Litecoin, Dogecoin, or any other proof-of-work blockchain. Okay. So now you might ask, okay, is this optimal? Is Ethereum optimal? Well, to answer this, you actually need to simulate all possible types of blockchains, proof-of-work-based blockchains that you can have there. So I've produced an open-source Bitcoin simulator with which you can do that. So what you can put into the Bitcoin simulator is, for example, different consensus parameters, like a block interval distribution, the mining power distribution of the mining pools. There are different network layer parameters. Actually, the network layer is one of the most important elements in scaling. The information propagation needs to be fast. You have a peer-to-peer network. It takes really time to forward a message. So Christian Decker did an awesome work on measuring information propagation in Bitcoin a few years back. And just to show you like a few numbers, so actually the geographic distribution of the nodes and the miners is quite important as well. So at the time when I measured, about 70% of the hash rate was in Asia Pacific. And if you look at the distribution of the nodes, it's actually about 50% in Europe. So the results of the simulator, I've simulated like quite many parameters. They are online available on the website, so you don't have to run the simulator yourself. You can just like look up the results. But there are some parameters that give you better throughput from a scalability point of view than those chosen by Bitcoin or those chosen by Ethereum. So just example parameter, because I'm not like a big fan of being religious about a particular constant. It's just an example parameter. If we choose a 1 minute block interval and a 1 megabyte block size, we get about 60 plus transactions. And according to my research, this doesn't change the security of the network. So the stale block rate, maybe some of you have heard it, so the number of blocks that do not confirm in the main chain does not change. So this means the security is not changed. The security is not affected by this change. Obviously, these parameters, or the security of those parameters changes over time, so this is only valid for the measurement at the time of the experiment. Okay, so we can scale maybe to 60, maybe to 100 transactions per second if we change the parameters of the current blockchains. If we only do parameter changing. Is that enough? It's not enough. So this is just taken like a few days ago, so almost 200,000 unconfirmed transactions alone in Bitcoin. That's huge. So these are transactions that are waiting to be confirmed. And that's why that actually also applies to Ethereum. I think in Ethereum, I checked, okay, you can read that, it's about 20,000 pending transactions. In the memory pool, I mean the pool that contains the unconfirmed transactions. And this is reflected finally in the fees. So in order to pay a fee to confirm a transaction in the blockchain, it's an arms race. It's a bidding war between all those that want to write to the blockchain. So the transaction fees in Bitcoin were about a bit more than $20 a few days ago, and in Ethereum more than $2, and I'm sure this is gonna go quite high this year, and disable actually many opportunities. So the main problem that I see of this high transaction fee, that it actually brings us back to a centralized system. So maybe you've seen the Liquor exchange, which was working and operating on the Bitcoin blockchain. It decided for operational purposes to switch back to a centralized system. Okay, so we're already seeing basically the effect on the decentralization of Bitcoin. And I think after all, most of us or many of us are in this field because we like the idea of decentralization. We like the idea of peer-to-peer. Right? Okay, so what are the blockchain scaling directions that we can take? There's one which is changing the consensus algorithm. At least this is what some people claim. So some people claim that if you change your consensus algorithm to proof of stake, you have more transactions per second. I have difficulties understanding this reasoning because proof of stake for me is just the concept of leader election or block election. And after all, this block which you create, whether it's proof of work or something else, or proof of stake, you still need to propagate it in the network. And if this propagation is not fast enough, then you're not really able to scale. So I think we should be a bit critical when people say we can scale through proof of stake. There might be, though, alternatives which take into account proof of stake and partitioning and sharding that might work out. So Definity, for example, is proposing a random beacon and at the same time a set of sharding. So this might be a possible way to scale. So I've already spoken about sharding. The basic idea is just to compartmentalize into different partitions the set of validating nodes. Okay? We're not talking about this today. Today we're talking about off-chain transactions. So those transactions that are basically confirmed on-chain later on. Okay? So what kind of blockchain scaling directions exist? So I would like to separate those into two classes. On one class, there are two-party payment channels. Okay, so these are channels between you and me, you and me, you and me, and you, right? So it's just like peer-to-peer direct payment channels. So they can be either unidirectional, so if I choose to only go with one, they can be bidirectional, they can be linked payments, which I will talk about in a bit, and they can be two-party payment hubs, so basically nodes that have many connections, many channels. But the other category that I think we need to consider as well are n-party hubs. So basically channels or off-chain technology which is not based on a two-party channel. And I would call them bidirectional n-party hubs, or just n-party hubs. Okay. So how does a off-chain payment work, or this life cycle of an off-chain channel? So the first thing that happens is typically a broadcast to establish the channel. So there are two parties here. They want to interact with each other. So they're happy. They broadcast a transaction that says we want to open a channel together. And then the miners start mining this transaction, which takes a bit of time. And then a lucky miner finds a block. And then this is registered in the blockchain. And we have this channel. Once this channel is open, then those two peers, they can transact off-chain because they have collateral in the blockchain, which allows them to use this collateral and only up to this collateral to transact with each other. Okay, so the off-chain transactions are secured by the on-chain collateral that has been put on before. In the end, if one of the parties wants to close the channel, they can just broadcast a so-called channel closure transaction, which is again mined by the miners. It's an on-chain transaction, takes some time, and it gets confirmed in the blockchain. Okay. So the first and most simple channel that we can think of are so-called unidirectional payment channels. So this means that party A wants to send off-chain funds to party B. So in order to do so, this party that wants to send funds needs to deposit some collateral. Let's say 1 Ether here. Okay? And once this is done, the party can send, well, we call it microtransaction because it's always smaller than the collateral, right? It can send one or multiple microtransactions to the receiving peer. So what you can see in blue here is actually the off-chain balance. So this is the balance that is not updated to the blockchain yet, but it's kept off-chain. So this is the book that the two parties keep. So bidirectional payment channels are actually quite similar. It's just the only difference is that now both parties put collateral there in the channel. Okay? What's important is that this collateral needs to be locked all over the time period that the channel exists, right? So it's actually a burden, and we will talk about this a bit later also. So now one party can send some off-chain funds, and the off-chain book gets updated. Then the other party can send some funds in the other way. The old off-chain book gets invalidated. It's very important. And the new off-chain balance gets validated. All right? Pretty simple. So now let's assume those two peers, they're actually not connected, not directly connected. They don't have a payment channel between themselves. So what can we do? Well, we can enable a so-called linked payment channel transaction. So if we have intermediate nodes that have open channels and, this is very important, where the deposit or the collateral put into the chain is actually sufficient, then you can do a linked payment transaction among different peers. So let's assume those peers, these are all unidirectional payment channels, and they have deposited 1 Ether, which they can use off-chain. So the leftmost peer can start, it's forwarded, and it arrives at the peer, and the off-chain balance is then adjusted by the individuals. So what I've omitted here is, for now, is that these peers that are forwarding off-chain transactions, they might take fees, right? I mean, why would they forward your payments? I mean, they maybe like you, but they're not doing much work for free. So there might be some fees that are being taken by the intermediate nodes. So there are a few considerations after seeing the concept of payment channels now. So first of all, I mean, finding the route might not be that easy. So there's a lot of information that needs to be exchanged. If you're familiar with internet routing, you need to communicate quite extensively to find another peer. and these channels or the routes that are possible to follow, they need to be kept up to date and live. Contrary to internet routing, I think one of the major roadblocks here is that you're not forwarding data packets. You're actually forwarding funds, right? So it's much more critical than, I mean, you don't really care if a data packet gets lost left or right, but if you're losing funds, this is much more critical. Another major issue is channel maintenance. So let's assume these peers are just continuing to send transactions in this direction. At some point, the collateral is used up. So why should the intermediate then update the channel for another person? It's expensive to do an on-chain transaction to update the channel. So transaction security is obviously something that everybody cares about. If the transaction security of the payment system is not guaranteed, and it's not a payment system anymore. So guaranteeing the security along the of payments that are sent along the path is critical. I think one of the major issues of payment channels that we have nowadays, two-party payment channels at least, is the problem that they are vulnerable to congestion of the blockchain. And we have seen congestion. I've just shown you on the slides that there are 200,000 pending transactions in Bitcoin. So these payment channels on a given timeout. So if you're not able to answer to a particular challenge on time for a payment channel, so if your opponent closes the channel with an invalid state, I mean with a state that you think is not valid, and you don't have time or you just don't have the resources to answer a challenge, then you're basically losing funds. Right? So, and this problem gets aggravated if more and more people want to close their channels. So blockchain congestion, I believe, is one of the major issues for payment channels. So, but there's, I mean, I've already briefly touched on it, but so one problem or consideration of payment channels are skewed balances. So let's assume we have this route from before, but the middle channel is now no longer usable. So what happens is we have to find another route. So this means another intermediate node, okay? And this means more relaying fees, more transaction fees. So we can send the payment now across this other node, but this is obviously an issue. So two-party payment channels deterioration penalties are, first of all, longer routing routes, and you have to keep them up to date, and on-chain top-up. So I'm presenting you now a solution that I've come up with, which is called Revive. So Revive is basically a method of making payment channels more scalable. So you need less on-chain top-ups. Okay? So how does this work? So in Revive, we basically produce a so-called rebalancing transaction set. So we developed an algorithm which allows you to find just a number of transactions that you can execute off-chain to rebalance the payment channels of your peers. So the input that you give to this algorithm is just current channel balances, and you might have certain preferences of how many funds you want to have in which channel. So the output of the algorithm is basically the payments that you need to execute. And the payments that we need to execute, we put them into a protocol that allows to enforce those transactions atomically. So atomically means either all of them pass or none of them pass. So here the input is just what we take from the previous algorithm, and the output is the execution or the failure of all payments. That's why it's atomic. So we have implemented a proof of concept on Ethereum using the Sprites payment channels. So it's open source. You can use it. It's available for anybody. So what we need for this is obviously we need a blockchain to execute it on. We need Turing-complete smart contracts, which are provided by Ethereum. We need two-party payment channels. So Sprites was actually a payment channel that we were able to use. We need a connected topology. So this works actually on cycles. We'll talk about this later. And we need some off-chain communication capability. Just means like internet connection between multiple peers. So how does this work? So how does this transaction set generation work? So we model basically the problem as a linear program. So we have two participants, U and V, and we have a particular transaction amount that we want to send from U to V that is modeled by delta U and V. Okay. So we can give to this particular program, we can give him, I mean, there are certain constraints that needs to be satisfied. So the first constraint is that all the incoming funds that you get should be zero sum with the outgoing funds. Okay? So rebalancing shouldn't change any balance, basically, right? I mean, it shouldn't change your overall balance. The second constraint that we have is that we need to account for some user preferences. So either you just make everybody halves their channels, so like equal preferences, or some of the peers, they might have particular preferences because some channels are more skewed than others. And finally, we have to take into account that the actual channel balances should not be changed. Right? So the overall funds between the channels should never change. So this is basically, we need an optimization algorithm. So the basic requirement is that the maximum, I mean the total amount of funds should, we should maximize the total amount of funds that are to be rebalanced. Okay. So as an optional strategy, we can say, okay, the default user preference is to balance each channel so that the off-chain funds that you have are just halved between them. Okay, so like equal amounts between the channels. We also support to bring your own strategy if you like to. It might make the linear program solver just more complex. So we prefer to use simple strategies. There's one issue with the linear program solver, because linear program solvers are basically, I mean, the output values are not integers but real values. So there might be minuscule losses when you solve a linear program. So basically what you can lose is the minimum amount of transaction unit that you can transfer in the blockchain. So in Ethereum, this will be 1 way. 1 way is 10 to the power of minus 18 ether. It's negligible. So the running time of a linear program is, I mean, the complexity of linear program solvers has been difficult to analyze. So the worst case running time is actually exponential. However, we have seen in practice that, well, the expected time is actually a polynomial time in the number of variables. So a number of variables would be the number of users that are participating in the solving of this linear program. So it's feasible. Okay. So how does this rebalancing protocol work? So what we have is basically, we have here a leader that we have to elect. So there's an initial setup phase, and in the setup phase we basically elect the leader, and the leader notifies the other peers that are participating in a particular rebalancing step. Okay. So what's very important is that all the participants that are participating in the rebalancing, they should freeze their current channels. So just so that the amount of the transaction funds which are frozen, they are constant. I mean that otherwise, if you can do off-chain transactions while you're rebalancing, then you just, I mean, this doesn't work. So what the leader receives, he requests from all the participants to receive their particular balances. Okay, so and this means that after they froze their channel, their different channels, the leader computes the transaction set. He solves the linear program given the constraints that he has been given by the users initially. So the next step is a signature aggregation. So that's very important. So the participants receive from the leader the transaction set that everybody sent to them. So this means the participant, he is only signing the transaction set if he's okay with the transaction set that would rebalance the channels. Okay. So then after the leader collected all the signatures, the leader basically distributes the full transaction set. So in case of disputes, rebalancing can be challenged on-chain. So the good part is that we can always recourse to the blockchain in case of disputes. Okay. So particular regarding the dispute strategy, so how can something be disputed? So in case something goes wrong, we use the underlying blockchain, and the dispute process basically relies on the underlying payment channel to be extended with the transaction set. So the underlying payment channel, so in our case it was sprites, it needs to be augmented to understand what rebalancing means. Okay. And then given the transaction set and along with all the signatures of the rebalancing, so we are basically we're broadcasting a Merkle rule in all the signatures of the transactions, and then we can basically we can resolve the dispute of a particular peer in the Revive protocol. Okay. So the security properties that we get are particularly interesting. I think the balance actually of honest participants always conserved. So you're sure if you participate in this protocol, you will not lose any funds. I think this is something that everybody wants, right? You don't want that your funds can be changed if you participate in an off-chain protocol. What's also important is that the rebalancing is done in a fair manner. So, and why is it fair? Because before you sign a particular transaction set to rebalance, you will see it. So you will never sign something that you don't agree with, and that's why it's fair. Regarding privacy, we're not making any guarantees. So the leader is basically requesting the channel balances of everybody that's participating. So the leader will know about the channel balances of the peers. So no privacy, but this is not something new. So future work. So regarding usability considerations, I would recommend, if you're using Revive, I would recommend you to only do rebalancing with peers that you already know. So reputation is important for practical purposes. You don't want to go to the dispute case and be required to do on-chain transactions to resolve disputes. So the number of participants, the more participants you have, the more signatures needs to be committed to the blockchain, so the more expensive the disputes get. So it should be within reasonable bounds. What's actually interesting, if you're using multiple channels yourself in the rebalancing scheme, it actually gets more optimal for yourself. Okay. And you should only use feasible optimization objectives. So, for example, this halving of the balance between two peers is reasonably simple. If you're using too complex optimization strategies, then the linear solver might not be more optimal, basically. So you might ask, okay, when can I do this rebalancing? So the problem is the problem is you can only do this if you have a cycle. So this topology is fine. This topology is not fine. So once you have a tree structure topology, you cannot apply rebalancing. But you can apply rebalancing as soon as you have a cycle in your graph. Okay. Very good. So the takeaways from Revive is that payment channels, if you use them, their quality will be deteriorated. So you will have skewed channels within one direction. You will need to top up some at some point. So either you do longer routing or you do top up, which is expensive. So you can use Revive to rebalance payment channels if you have cycles in your topology. So what we have shown you is a rebalancing transaction set generation algorithm. So it generates the set of transactions to rebalance off-chain and a protocol to implement that. So the code is available on this GitHub link, and the academic paper that was accepted at the Tier 1 conference is available there. Good. But what kind of other two-party payment solutions are there? Well, there's Lightning. I guess everybody heard of it. There's Raiden, and there's, for example, TumbleBit. So Lightning was presented a few years back in Scaling Bitcoin Hong Kong. There's so much effort going on in Lightning that's really great to see. So Lightning is already running a testnet. There are different nodes being 800 nodes are currently live in the testnet. It's a two-party payment channel solution. Some peers are already running it on the Bitcoin main chain. I don't know if this is a good idea, but we will see. It's a bug bounty. And Raiden is doing payment channels on Ethereum. They have already published for the mainnet unidirectional payment channels, which everybody can use. So you can already use those channels, in particular the implementation if you want to. So I think it's also a great effort on this side. TumbleBit is another project that might be less known, but I think it's very interesting. It actually is a Bitcoin mixer by default, but it can operate as a hub, or like as a two-party payment hub, I would call it, in the sense that it is more privacy preserving. So it allows you to use off-chain transactions in a privacy preserving manner. Okay, so you can't link the input to the output transaction. And now I would like to ask you, what do you think is this topology? From which network does this come from? Lightning, I heard Lightning. Okay, very good. Yes, it's Lightning, and it's the testnet a few days ago. And what can you see there? What kind of structures do you see?
Hub and spoke.
Exactly. So we're actually seeing in real life that it seems there's some kind of hubs evolving, right? So naturally, some of the nodes are going to have more connections than others. So there's going to be some kind of a distribution which tells us there will be some really heavy nodes and many with very few connections. So in Lightning, you would create such a hub by doing something like this. So bi-directional channels, and the node in the middle would be called the two-party payment hub. So this node needs to actually lock quite some collateral, right? It actually needs to lock collateral for each individual peer here. If it's a bi-directional channel, there's obviously also on the other counterparty some collateral deposited. So the problem is you have to maintain that. There's a lot of frozen deposit, and in particular, if you're just looking at the deposit from the hub, here in this particular example, let's imagine there are like transactions coming in there, transactions coming in there. So it seems that the leftmost node here receives more transaction volume than the other nodes. So how can you anticipate this as a hub operator? And that's really hard, right? You don't really know. I mean, you have to basically anticipate how much incoming funds you get from other peers to a particular peer to optimize collateral for each channel that you're having here. This means on-chain top-up. I don't like on-chain top-ups. Nobody likes it, right? So what I'm working on is the Liquidity Network. It's basically a project to build efficient off-chain payment hubs, because we believe that off-chain payments are going to be there, and they're complementary to two-party payment channels. So we need both technologies, but we need efficient hubs. So what we're currently working on is to get basically a payment hub which has very low setup costs, it has low maintenance costs, it has in particular failure safety on blockchain congestion, so it shouldn't be as vulnerable to blockchain congestion as typical two-party payment channels. And we want to support at least 100,000 users per hub, okay? Which would be quite significant achievement. So the architecture is rather simple. So I'm not showing, we don't have any technical write-up yet as of today. But just to give you an overall picture, so we still have the blockchain, we have a smart contract, that is the Liquidity Network smart contract, we have an off-chain Liquidity Network server, and this is basically an off-chain hub, right? So this is the overall architecture, as also is the case for typical two-party off-chain payments. So our goal is to build an open source to run a hub if they want to. And the good part is that we can actually also use Revive, our protocol for rebalancing, among different hubs. So if you were to set up, for example, 3 different hubs, they can actually be connected in a cycle and they can just rebalance their transactions. So it's again increasing the scalability of those hubs. So one thing I would like to discuss briefly is the off-chain registration process. So one of the beauties, I think, of the hub is that if you're a new user and you want to join this hub here, you can actually perform an off-chain registration for free with a hub. You're just sending a TCP message to the hub with your signed Ethereum address. And then another user can actually send you an off-chain transfer, which you can directly forward. So there's no need for you to do any registration, like any deposit, any on-chain transaction. So new peers can actually join and already receive off-chain funds. And for example, they could pay in some fiat currency and get off-chain funds directly, right? So you actually never handle on-chain funds anymore. So yes, it will be interesting to see how this evolves. So we have one demo of the wallet up on YouTube. If you want to check out the wallet, how it would work. So this was recorded basically from our internal testnets. And so we are working on the deployment on Ethereum. So we will deploy the testnet in Q1 of this year, and also release more technical specification. I can just encourage you to join our Slack in the meantime or follow us on Twitter. So regarding scaling, so to summarize today, regarding scaling, we have different scaling opportunities. I think reparameterizing blockchains isn't gonna work, but still we need to understand the best limitations of the on-chain parameterization. So it's possibly that we can go above, up to 100 transactions per second with light changes. Sharding and off-chain transactions is another way to scale. On the one side, for off-chain transactions, there are two-party payment channels, different types of payment channels that you can think of, and there are also n-party payment hubs that I believe will be necessary to actually scale. Thank you very much. I'm happy to take your questions. Yes?
Well, I have a question. I don't know if it's relevant, but is there any relationship between like the 200,000 unresolved transactions that are out there and the rising price of those transactions and the actual cost of Bitcoin? Like, is there a relationship among that or not?
You mean between the number of unconfirmed transactions, the transaction fees for a transaction to
and
put?
The actual cost of Bitcoin. Like
what?
The fluctuation in the price of the coin itself, is it affected at all by those two things?
I would say the price of Bitcoin doesn't matter too much, although it's true that the transaction fees, they just halved because the Bitcoin price halved. So it should have an impact there. I don't think it's not uncorrelated, but
It's not driving the change in the price. It's actually, but it's correlated.
I think the transaction fees they should drive the price down because it makes the chain less usable.
Right.
It makes corporations go from a decentralized to a centralized model. I mean, it's just it makes you lose interest. Yeah.
I came in a bit late. Sorry for that. Can you explain why the transaction costs are so high?
It's because there's too much demand.
Oh, okay.
But it's also because some corporations are not batching transactions. So you can actually try to write more efficient transactions where you batch together many of your customers' transactions. And I think there's quite some room for improvement probably on this front.
So when you have too much demand, why there is no offer for it to?
Why there's no offer? Because in Bitcoin you just have a limited capacity. So the capacity of transactions that you can process is limited by the block size, right? So how many transactions can you fit in, and the interval, like the time frequency at which you generate blocks. So it's just that. So if you have 1 megabyte every 10 minutes, that's your limit, and the transaction is on average 250 bytes or something.
I understand that there are different ways of implementing microchannel transactions.
Mm-hmm.
And in the end, what would be in an ideal world, it would be that the Bitcoin core team agrees to implement a unique manner of doing micropayment transaction for all the clients of Bitcoins. And do you think that at some point the core team will agree on one implementation that will be widely adopted. Otherwise, we may end up with different ways of doing micropayment transaction, and it may create a little bit of mess. I don't know. Like, what is your view on this competition, and how do you think it is realistically possible that the core team agrees on a single way of doing that?
So it's a very good question. I would just be cautious with saying the core team, because then you imply a centralized party, and then you imply these are the only ones that decide, right? Which is not the case.
They have a lot of power anyway, so their voice is very important.
It's true. I would say the majority of the peers agree. I would put it like this always, but you're right. It's not that easy. But coming back to your actual question, you're very right. We need a standard, and Lightning is actually working very well on that. I mean, the Lightning the Bolt specifications, they explain very well the standard of how to perform off-chain transactions in Bitcoin. We are trying. I mean, actually, with Liquidity, we want to be compatible with them. It will take some time. Because we first have to get basically our testnet running and understand, and basically just get the feedback from the community as well to some degree. But I think compatibility is key. So it's important to not brew your own kernel, but to actually be compatible with others. I think that's true. Yeah, Reto?
What's the process of redirection?
In Revive? It's just round robin. So there's no fancy leader election algorithm. So if you have a set of different peers, you can just have a round robin between the different peers.
What's the process of being elected a candidate for being a leader?
You can just decide like on a random leader. It doesn't really matter from a security perspective. It's just you need like a particular node that basically tells everybody, hey, freeze your channels, that gets all the signatures from everybody and then sends them the result.
Okay, but does it need to be the hub?
No, it doesn't have to be the hub. No, it can be anybody in the. Okay, it can actually be an external party. Yeah, it doesn't have to be a hub. Good question. Yes.
I can't really see why off-chain rebalancing in the Lightning Network wouldn't work if you have closed loops in the Lightning Network.
Oh, I think it will work. I mean, it's just for easiness. We have implemented it on Ethereum with the Sprites payment channels, which is an Ethereum-based payment channel implemented by Andrew Miller and other great researchers. But I think should certainly work on Bitcoin.
Yeah, because you said that you need these Turing complete smart contracts.
True, you're right. I mean, it's not absolute. I would need to verify. I haven't thought over it in depth, but it's likely that you don't need it. Yeah, it should be able to run on script as well. Good question. I mean, for researchers, it's just easier to do prototypes in Ethereum because Solidity just gives you more flexibility.
Not only for researchers.
I agree. But we're going to production with some research too. Okay. Yes.
So Raiden has been live for a while now, right? Why do you think that there's still a backlog on Ether? Why haven't, like for example, why doesn't CryptoKitties use Raiden?
You have to differentiate between payments and state.
Okay.
So CryptoKitties is a smart contract where you likely need state channels and not payment channels, right? Payment channels is only for transmitting funds.
Yes.
So
I presume that is true for ICOs as well?
no, in ICOs you're transmitting funds.
So then, why is there still congestion in Ethereum?
Well, how do you run an ICO over micro Raiden? So you would need to, before you basically you do a unidirectional payment channel to your favorite ICO, and so this needs to be done on chain, right? And then you send them little, like smaller transactions than your initial deposit, right? So why would you do that? There's just there's not a real. I mean, at least I don't see how this would work. If, however, you have already some amount of funds off chain in a network, for example, in a hub, or in some Lightning network. If you already have some off-chain funds, then you could just forward them to your favorite ICO. Right? This could work. Good question. Yeah.
There's also some talks about plasma, no? And I was wondering what's the main differences between this Lightning solution and other solution and plasma sidechains.
That's a good question. I would say the main difference is that you actually have sidechains here, and I wouldn't call a payment channel a sidechain. So this is the main difference.
But because a few years ago, sidechains there was a lot of discussion about that, and then
Yep.
they went out of favor, and why now there's some revival of that?
I don't know. I would also be happy to get more technical details on Plasma, how this would actually work. I mean, I understand that it takes some time to develop that. I mean, even Liquidity, we are not yet able to disclose like all the technical details. Yeah, it will. I think we need more details on how it would actually work, the Plasma. Yeah. Yes.
Yeah, you talk about blockchain scalability, but what's your take on DAGs? So,
Like
On decentralized?
stuff.
like, yeah.
Decentralized exchanges?
No, DAGs. Like
Directed and cyclical growth.
Ah, okay. So promising 0 transaction fees is not a good idea, I think. Actually, transaction fees have a purpose, right? They should prevent spam. So I think we still need to do quite a lot of research on the DAG systems or IOTA-like systems to understand whether they are secure as they are proposed to. Having a coordinator, even only a temporary coordinator that you say is only necessary at the beginning, doesn't make too much sense to me. But maybe I'm missing something. So I'm happy to again, like Plasma, I'm happy to understand more, and we need thorough security analysis of this. I mean, even for like standard proof of work blockchains, we don't know why 6 block confirmations are enough, right? So before going ahead and like proposing the next big thing, we should really go a bit back and understand what we're actually doing right now.
I mean, there's not only IOTA, but also things like Spectre,
Yep.
Which don't kill the blocks and don't kill miners, like IOTA, and they have still transaction fees.
Okay, I haven't looked into the detail in Suspect. I would need to look into that.
Because you mentioned also the fees about this off-chain solution, and I think also that the discussion about Bitcoin is because every miner, every node can decide by itself the fees. It's not decided by the chain. And I was wondering if there is on this approach there is some ideas to have a controlled fee market that people cannot abuse to abuse the system, maybe to spend the system to increase the fees and this kind of optimal attitudes.
So I think the market should go towards, if we're talking about off-chain providers, let's say off-chain providers in general, whether two-party, hub, or whatever, right? I think the market will go towards solutions that favor less fees, right? I mean, it should just be like this, that if you have a hub or if you have some peers that connect you to others off-chain and they just take less fees, they will be favored. There's a cost in changing your connections because you have to do on-chain transactions, closing one transaction, opening another transaction. But ultimately, I believe the network will go towards the cheapest transaction fees. So, yeah.
What I mean is that was also the input about the core team is that there is a lot of groups and to decide which technology we win, and there is also a lot of manipulation, no? Because to resolve these issues now there is a lot of fights, and sometimes there is also the fee market is manipulated to push people on one network on another, and this is not optimal.
Where's the manipulation?
Yeah, like if you sometimes also on the chain, of Bitcoin chain, you see that the blocks can be full at a certain point, and suddenly it stops because some people that were spamming by purpose the chain.
Well, spamming the chain costs you, right,
Yeah,
quite a
yeah.
lot of money.
A
So
lot of money you can afford to manipulate.
I don't know. I haven't made the calculations.
Because there are some research about that. You saw some outliers and some
Okay.
strange stuff.
I think, I think that, I mean, with off-chain transactions, I think the market will be rather clear. I mean, it will just like people that, because you don't, actually, many peers will be able to provide off-chain services. Not many peers can do mining. So it should be a bit more competitive. Yeah. Yeah.
So a question on this slide, this payment hub looks like a bank. So is it then centralized solution inside the decentralized blockchain to make it more efficient?
It's a very good question. Thank you. So indeed, it's a single point of failure if you have only one. So that's why we envision this to be open source. So anybody that wants to can create a hub. So there will be a network of hubs that you can connect to. And obviously there will be some peers or some hubs that have like much more connections than others, just like as you've seen in the Lightning testnet, right? So if a particular hub is just too powerful or is abusing its powers, then people will change. Now, what can a hub do actually to abuse its power? What's the worst thing that can happen? It can actually deny transactions. It can allow you, it can deny to forward transactions. That's so bad. It's a denial of service, yeah, but if you have a congested blockchain, then you just can't do anything as well, right? So I think the worst case scenarios are not that bad. And it's not a bank because it doesn't have funds it doesn't have access at any point to your funds. Right? So that's a fundamental difference, and this is why we are in blockchain, I guess, also.
Still one more question?
Yeah. Yes.
So one thing I don't like is the leader who knows who gets how much funds. Is there a way of doing some secret sharing algorithm?
I'm sure you can do some multi-party computation to improve that, which would reduce the efficiency and increase the communication among the peers. But certainly, yeah. I mean, we have been proposing this just as a means to show that you can actually do off-chain rebalancing and you don't need on-chain transactions. But privacy is something that everybody needs to work on, and that's why I also put up TumbleBit, right? Because they are actually working to improve the privacy, and I think this is very important.